The German experts called it impossible. The Japanese management was panicking. A single, tiny flaw had brought their entire $100 million operation to a screeching halt, and the losses were piling up faster than anyone could count. In the high-stakes world of automotive manufacturing, this kind of unplanned downtime can cost a company up to $2.3 million an hour. For Osaka Precision Automotive, a key supplier to some of the biggest car brands in the world, this wasn't just a cost, it was a catastrophe. But what they didn't know was that the one person who held the key to saving them all wasn't a high-paid expert or a senior manager. He was a Filipino worker named Miguel Santos, and he was about to become a legend. In the hyper-efficient, fiercely competitive world of Japanese manufacturing, there are stories that get passed down from one factory floor to the next. They're whispered over lunch breaks and shared between shifts, modern fables about impossible problems and unlikely heroes. These stories often sound a little too good to be true, but they carry a powerful lesson. This is one of those legends. Now, you won't find this story in official company histories or news archives. Our story is set in a fictional but highly realistic plant we'll call Osaka Precision Automotive. This factory is the pinnacle of Japanese industrial might, a sprawling complex of robotics, high-speed assembly lines, and unforgiving quality control. Here, thousands of parts become complex transmissions for luxury cars, a place where a tenth of a millimeter mistake can cause a catastrophic failure. And in this world of relentless precision worked Miguel Santos. 32 years old, Miguel was one of thousands of skilled Filipino workers who come to Japan for a better opportunity. He was part of the Technical Intern Training Program, or TITP. On paper, this government program is designed to transfer skills and technology to workers from other nations. In practice, for many like Miguel, it was a shot at a better life and a way to support his family back home. However, the program has its dark side. It has faced heavy criticism for cases of exploitation, sometimes acting more as a pipeline for cheap labor than a real training program. General knowledge. Workers can feel isolated, unable to change jobs, and completely dependent on their employers, leaving them vulnerable. So, Miguel's journey wasn't just about learning new skills. It was about navigating a tough system far from home. He wasn't a hotshot engineer from a fancy university. He'd learned his trade the hard way, fixing ancient machines in the bustling factories of Manila. He was quiet, observant, and he just understood machines. His co-workers saw him as a diligent, reliable guy, but he was basically invisible to the management. He was a face in the crowd. No one knew the depth of his talent or the power of his silent observation. He simply did his job, kept his head down, and sent money home. But every single day, he was watching, learning, and noticing things nobody else did. The crisis started not with a bang, but with a hum. A barely perceptible high-frequency vibration on the final assembly line for a brand-new, state-of-the-art transmission. This wasn't just any transmission, it was for a flagship luxury sedan made by a major German automaker. A 9-figure contract, the biggest in the factory's history, was riding on it. At first, the vibration was shrugged off as a statistical anomaly. But then, the rejections from quality control started piling up. Microfractures were appearing in the gears. The official diagnosis? Catastrophic failure from harmonic resonance, a fancy way of saying the machine was shaking itself apart at a microscopic level. The problem was a tiny error, a misalignment of just 0.2 millimeters in a critical part during high-speed assembly. Then the alarm shrieked through the factory, signaling the unthinkable. The line was shut down. In a place where the constant rhythm of production was its heartbeat, the silence was chilling. Every minute the line was down, the company was hemorrhaging money. The auto industry is brutal. For critical failures, downtime costs can soar into the tens of thousands of dollars per minute. For Osaka Precision Automotive, the financial bleed was bad, but the damage to their reputation would be worse. The first shipment to Germany was due in 2 weeks. Missing that deadline wouldn't just mean a penalty, it would mean losing the contract and the trust of the entire automotive world. The panic in the executive wing was immediate. CEO Kenji Tanaka, a man known for his calm demeanor, was visibly shaken. He had built his career on Kaizen, the philosophy of continuous improvement pioneered by Toyota, but this problem couldn't be solved with small, ongoing changes. This was a full-blown breakdown. Tanaka made the only call he could. He brought in the best. A team of elite German engineering consultants was flown in from Stuttgart. These were the experts' experts. They arrived with supreme confidence, armed with laser scanners, acoustic analyzers, and sophisticated software. For 2 days, they mapped the machinery, ran simulations, and analyzed terabytes of data. They recommended a multi-million-dollar fix involving a complete recalibration of the robotic arms and a new cooling system. Deferring to the high-priced experts, the factory engineers started the work. The shutdown stretched from 1 day to 3 to 5. The costs ballooned past $20 million, and it didn't work. When they restarted the line, the vibration was still there, angrier than before. The German team was baffled. Their data was perfect, their models flawless, but reality refused to cooperate. Meetings grew tense. The Germans insisted on trusting their instruments, while the Japanese managers urged a more hands-on approach. Finally, after a week of failures, the lead German consultant delivered the verdict. Standing before Tanaka and the board, he explained the problem was an inherent design flaw. The only solution, he declared, was a 6-month retooling of the entire line. When Tanaka explained that would bankrupt the company, the consultant just shrugged. The problem, he said flatly, is impossible to solve in the time you have. That afternoon, the German team packed their bags, collected their huge fee, and left. Desperation turned to despair. The engineers were defeated. The workers were told the shutdown was indefinite. CEO Kenji Tanaka, a man who had dedicated his life to industrial perfection, had done everything by the book. And now, his company was on the brink of collapse because of a problem no one could solve. Throughout this entire week of chaos, Miguel Santos had been watching. While the German experts were buried in their laptops, Miguel was practicing a core principle of the Toyota production system, Genchi Genbutsu. It's a Japanese phrase that means, go and see for yourself. It's the belief that you can't truly understand a problem by looking at data on a screen. You have to go to the actual place, the Gemba, and observe the actual thing. So Miguel went. He spent hours standing by the silent machine long after his shift would have ended. He didn't have fancy equipment. He just had his eyes, his ears, and that gut feeling you only get from years of hands-on work. He talked to the other line workers, asking about the little things the experts had dismissed. They told him about a slight change in the hum of the conveyor belt just before the vibration started. A tiny shudder when the robotic arm placed the component. These were things you couldn't find on a spreadsheet. While the experts looked from a distance, Miguel got up close. He ran his fingers over the surfaces. He watched the light reflect off the metal. He spent a whole night just standing there, observing. And then he saw it. It wasn't some major flaw. It was impossibly small. As the component was placed into its housing, there was a microscopic bounce, a tiny moment of instability before it settled. This bounce, happening hundreds of times a minute, was creating the vibration. The harmonic resonance the Germans found was just a symptom. This tiny bounce was the disease. The experts, with all their technology, had been measuring the earthquake while completely missing the tiny shift in the plates beneath. His mind raced. What if he could introduce a tiny delay, just 1/10 of a second? It would let the components settle. But how to stabilize it? He needed a shim, a simple, thin piece of metal, placed at a precise angle to cushion the landing. He sketched his idea on a piece of cardboard, a simple metal shim, and a single line of code to change in the machine's brain. A 0.1 second delay. It was an idea born not from complex equations, but from humble observation. Getting anyone to listen was another story. He was a foreign intern, a nobody. His supervisor waved him away. In an act of quiet desperation, Miguel waited outside the CEO's office. When Kenji Tanaka emerged, looking utterly defeated, Miguel stood in his path, bowed deeply, and held out the piece of cardboard. Tanaka was about to brush him aside, but something in the young man's eyes, a mix of respect, urgency, and absolute certainty, made him pause. He looked at the crude drawing. He listened as Miguel, in his careful Japanese, explained his theory. It seemed absurdly simple compared to the multi-million-dollar failures. But Tanaka had nothing left to lose. He looked at Miguel and made a decision. "You have until sunrise," he said. "The factory is yours." That night, Miguel became the commander of a ghost factory. He assembled a small, skeptical crew. He found a scrap of high-density steel and, using the workshop tools, meticulously hand-filed it into the exact shape he had imagined. He then went to the control panel and, with a steady hand, edited the code, adding a single command: wait 0.1 seconds. He installed the shim himself. The entire fix took less than 4 hours. As dawn broke over Osaka, the test began. Tanaka and a handful of grim-faced managers stood watching. Miguel took a deep breath and pressed the start button. The line whirred to life. The robotic arm placed a component into the housing. And then, a split second of silence. The 0.1 second delay. The assembly engaged. The finished transmission rolled off the line. An engineer rushed it to the testing bay. The diagnostic machine, which had been flashing red for a week, ran its analysis. Everyone held their breath. A moment later, a brilliant green light lit up the screen. Pass! They ran another. Pass. Then 10 more. All perfect. The vibration was gone. All that was left was the clean, rhythmic, beautiful sound of a perfectly working factory. A wave of stunned silence washed over the managers, quickly followed by ripples of laughter and applause. Miguel's simple, elegant solution had worked. The impossible problem was solved. The contract was saved. Later that morning, as the factory hummed with renewed life, CEO Kenji Tanaka walked onto the floor. He went directly to where Miguel was quietly observing the line. In front of hundreds of workers, the CEO of Osaka Precision Automotive, a man at the top of Japan's proud industrial hierarchy, bowed to the young Filipino worker. It wasn't a simple nod. It was a deep, formal 90-degree bow, the highest gesture of respect and gratitude in Japanese culture. In that single, silent gesture, he acknowledged that the company's salvation came not from expensive consultants, but from the quiet wisdom of a man who simply knew how to see. The story of what happened next is part of the legend. Miguel Santos was immediately promoted to Process Improvement Specialist, given a team and the authority to apply his methods across the factory. And that simple, hand-filed piece of metal? It was encased in glass and placed in the lobby of the company's headquarters. it became known as the Santos shim, a permanent reminder that the most brilliant solutions are often the simplest, and that genius can be found where you least expect it. The legend of Miguel Santos is a powerful reminder that a title doesn't determine your value, and a degree doesn't own a monopoly on insight. True expertise is forged in experience, and the most critical observations often come from those on the front lines. It's a story about the triumph of humble observation over arrogant theory. It shows that heroes don't always wear capes. Sometimes they just wear a factory uniform. Have you ever witnessed an everyday hero at your workplace? Someone with a simple, brilliant idea that saved the day? Share your story in the comments below. We'd love to hear it. And for more incredible stories about the unsung heroes who shape our world, don't forget to subscribe.